NASA's TESS mission has found its first Earth-sized world in its star's habitable zone. This means the planet, called TOI 700D, has the potential for liquid water on its surface. TESS stares at patches of sky for long stretches, recording light from thousands of stars. Some of these stars have planets that cross or transit in front of them. TESS sees these events as tiny, regular dimmings of the host stars. One star where TESS saw transits is TOI 700. It's a red dwarf about 40% the mass and size of our Sun and roughly half its temperature. One set of transits announced the presence of a planet close to the star, called TOI 700b. Another set revealed a second planet named TOI 700c a little farther out. The deeper, shorter transit means the planet is larger than the first, and the plane of its orbit is slightly tipped. A final set of transits showed TOI 700D orbiting even farther out. TESS observed this system for nearly 11 months and saw each planet transit multiple times. Scientists determined that the inner and outer planets are almost Earth-size and may be rocky. The middle world is more than twice as large and most likely made of gas. All three may be tidally locked, rotating just once each orbit, so the same side always faces the star. But most importantly, TOI 700D is within the star's habitable zone. Scientists wanted independent confirmation of TOI 700D, so they monitored its star with NASA's Spitzer Space Telescope. Spitzer saw a clear transit from the outer planet, affirming its existence and improving scientists' certainty of the planet's size. TOI 700D is one of only a few Earth-sized planets found in potential habitable zones. Others include discoveries by Kepler and several planets in the TRAPPIST-1 system. Because TOI 700 is bright and nearby, the planets are good candidates for precise mass measurements by ground-based telescopes. Future missions may also tell us if the worlds have atmospheres, but scientists need to know what kinds of signals to look for. Researchers at NASA's Goddard Space Flight Center created models of the planet to explore its potential conditions. One version is a water-covered world with an atmosphere similar to early Mars, but denser. Another looks like a completely dry version of today's Earth. Both models have vastly different surface temperatures. Light passing through their atmospheres creates distinct signals because different molecules are present. By simulating these data now, scientists can make predictions for real future observations and narrow the range of TOI 700D's possible conditions. We still have much to learn about the TOI 700 system, but thanks to TESS, Spitzer, and the work of many scientists, we're beginning to form a picture of its exciting new worlds.